All right, welcome. It's Friday the 23rd. I'm sorry I can't be there, but I am here. We're going to get through a lesson today. We're going to learn how to use long division in algebra. First thing I want you to do, though, is to factor using the GCF. Please factor this expression by taking out a GCF. We're going to pause this and come back, and you're going to see the answer. You've got 90 seconds. Go. All right, I see this looks a bit messy because I'm using a tablet at home to record this lesson. But do you notice that when I took out the GCF, this is what's left over, and I better write my GCF. I'm going to put it over here. So I want to ask you guys, what is happening with this bar here in the 4ab squared? What am I asking you to do? I hope you know I'm asking you to divide. You already know polynomial long division because you've been doing it. Okay? Pretty cool. All right. Your learning target, your focus for today is that within factoring polynomials, we're still in IF5, but you're going to use long division to divide a polynomial by a monomial or another polynomial. So basically one or two terms, maybe even bigger. But that's what we're going to do today. You can pause this, give everybody a minute to write it down, but we're using long division to divide polynomials. Okay. Do you remember how to long divide? So I'm going to go through this because we're going to use the same division algorithm. The same thing you learned back in 4th grade, we're doing here. So 7, does 7 go into 5? Nope. But does 7 go into 54? It does, and it goes there in there 7 times. Notice I'm aligning this over the this is the hundredths, this is the tens place. 7 times 7 is 49. Do you remember what we did when we got to this point? We subtracted, and we said 54 minus 49, that is the number 5. And then, remember, we dropped this 3 down, it's in the ones place, and then we said, hey, how many times does 7 go into 53? Well, that's 7, and 7 times 7 is 49, and now I have a remainder of 4. So what we get is 77. 7 goes into 543, 77 times remainder 4. Let's try this with something a little bigger. So we're going to divide 375 by 25, and the first thing we do is say, well, how many times does 25 go into 37? It goes in once, and we write down 25, and then we subtracted, and 37 minus 25 is going to be 12. And then remember, I dropped the 5 down. And how many times does 25 go into 125? Well, isn't that 5 times? You could use your calculator, or you could count by 25. 25, 50, 75, 100, 125. So that goes in there 5 times. So 5 times 25 is 125. And we have 0. So a remainder of 0. How could we check our work? Well, to check our work, we could take our answer. What is 15 times 25? And I'm going to do this multiplication, and I'd like you to do it too to double check. So this is the old-fashioned way. If you did lattice, go ahead and use lattice. 10 add a 1. So it's true that 25 times 15 is 375. So that's what we're going to do with polynomials. All right, use long division to find x squared plus 2x minus 24 divided by x minus 4. So x minus 4 gets written outside my division bar. I do, oh, I forget what that thing's called. I'll have to figure that out. Underneath, I think it's called the vinculum. Sounds like a disease. We're going to have x squared plus 2x minus 24. Things we need to look out for. Standard form. We need to look out for standard form, and we need to look out for missing x's. Those will come up later. So what we're going to do is I'm going to ask myself, how many times does x go into x squared? So this is step 1. Off to the side, I'm going to take x squared divided by x, and we all know that's x. So I'm going to write x up here. Now I'm going to do some multiplication, and I want you to write this out over here. I'm going to take x, and I'm going to multiply it by x minus 4. And when I figure that out, I'm going to write the result underneath, just like I did in the other example. X times x is x squared, and x times a negative 4 is a minus 4. Okay? Now I'm going to come through and I'm going to subtract. So when I subtract, what that means is I'm going to change all my signs. This becomes a minus, and that becomes a plus. So x squared minus x squared goes to 0. Whoops, I should have written an x here, shouldn't I? Somebody who caught that? Jacob, thank you. So 2x plus 4x gives me a 6x. And then I drop my minus 24 down. Now I'm going to go back to my second part, and I'm going to say, how many times does x, just the x, go into 6x? So 6x divided by x is the number 6. So I'm going to write the number 6 up here. And now, off to the side, next to my work, I'm going to take the 6, and I'm going to multiply by the number x minus 4. That's my divisor. Whoops, my pen's messing up. Sorry, guys. Let me undo that. Undo. Okay? So what is 6 times x minus 4? Well, I get 6x, and I get a positive 24. I'm sorry, I get a negative 24. I get a negative 24. That's a minus 24. Now I'm going to come through and I'm going to subtract. When I subtract, I change all the signs. That becomes a negative. That becomes a positive, so I get 0. So this is the deal. I can say, remainder 0, that x minus 4 times x plus 6 equals x squared plus 2x minus 24. Okay? So when I ask you to divide using long division, you're going to use this process, and our answer is going to be x plus 6, remainder 0, and this is really what this means. All right, let's try this one. Use long division to find. So we've got to make sure something's in standard form, and that means t squared, a t term, and a constant. And I've got it. There's my t squared, t constant. So on the outside, my divisor, 2t plus 3. I want you to make a nice big division bar. I think it's a vinculum. 2t squared minus 17t minus 38. And now what I'm going to do, my first step is to take 2t and see how many times it goes into 2t squared. So here's my side work, 2t squared divided by 2t. That simplifies to t. So that is what comes up here. So I write down t, and then I'm going to multiply it by my divisor, 2t plus 3. And now I'm going to distribute. And I get 2t squared plus 3t. Then I draw my line. And I subtract. When I subtract, I change all my signs. This becomes a negative, and this becomes a negative. So when I combine these two rows together by combining like terms, that goes to 0, and negative 17t minus 3t is a negative 20t minus 38. Drop that down. So next step, how many times does 2t go into minus 20t? So minus 20t divided by 2t gives me negative 10. So negative 10 gets written up here. And then I write down minus 10. And I write down the divisor, 2t plus 3. And now I do some multiplication. So I get minus 20t. And then I get a minus 30. And I come through and I change my signs. When I change my signs, this becomes a positive and this becomes a positive. So minus 20 plus 20 goes to 0. A negative 38 plus 30 is a minus 8. And this is where I stop. So my answer is t minus 10, remainder negative 8. T minus 10, remainder negative 8. Okay? All right, here is a gotcha. So standard form. I should have an x squared term, I should have an x term, and I should have a constant. And do you notice I am missing an x term? So when we write this, I'm going to put x minus 8 on the outside. I'm going to write my division bar. I'm going to put a placeholder in here. I'm going to do x squared, but I'm going to write plus 0x minus 74. This is really important. This is going to keep us sane and we won't have trouble. So that's my placeholder. That's my plus 0x. So my first step now is to figure out how many times does x go into x squared. So we should know this by now. This should be x. And now what I do is I write down x times x minus 8, and I distribute. And I get x squared. And then I get a minus 8x. And notice, because I have my placeholder, all is happy in the world. I'm going to come through and I'm going to subtract, and that means change all the signs. So that goes to 0. And then I get 8x minus 74. Remember, I dropped the 74 down. Now here's my next piece of side work. How many times does x go into 8x? So 8x divided by x gives me the number 8. And that's positive, so I write down plus 8. And off to the side, I'm going to write my 8 and my x minus 8. And I'm going to distribute. And I get 8x minus 64. Then I'm going to come through. Whoops, my pen broke. And I'm going to subtract, and that means change all the signs. So that goes to 0. This gives me a negative 10. So the answer is remainder, negative 10. How's that? Not bad? All right. Here you go. I want you to use long division to find the quotient and the remainder, not the reminder, the remainder. I'm going to put the solutions up here in a minute. So you have to do all three problems. This is problem A, this is problem B, and this is problem C. Good luck. Okay, we're back. Check your answers. Did you get x minus 1, remainder 9, p plus 7, remainder 10, and b plus 5, remainder negative 3? Okay, did you get 1 out of 3 right, 2 out of 3, or 3 out of 3? Here is the work for the first one. You can pause it. Everybody can write this down if you didn't get it. Come on back when you're ready. For the second problem, you can pause this, write this down, come back when you're ready. We'll have plenty of time to practice, I promise you. Number 3, did you get the gotcha and put in the placeholder 0b? That's the problem, is we're missing that. If you need to write this one down, please pause this and come on back. All right, you're back. So now we're going to talk about checking factors, and I want you to write this down. I want you to write down checking factors. I want you to write down, is x squared plus 1 a factor of this? And here's the deal. If the remainder is 0, the expression's a factor. If the remainder isn't 0, then the expression is not a factor. So here's an example using numbers. Is 7 a factor of 42? This is what we're really asking you to do, but with algebra. Well, 42 divided by 7 is 6, remainder 0. So yes, 7 is a factor of 42. But how about one that isn't? Is 7 a factor of 25? Well, 25 divided by 7 is the number 3, remainder 4. So no, 7 is not a factor of 25. Does that make sense? Okay, so if my remainder is 0, the expression is a factor. If my remainder is not 0, it's not a factor. What's this going to look like? We've got something called the factor theorem, and I want you to write this down. The factor theorem says that I can write a polynomial as a product of its factors plus the remainder. So there's my divisor, there's my quotient, there's my remainder. Okay, so any polynomial can be written in this form. Any polynomial can be written as divisor times quotient plus remainder. And that's what I have right here. The polynomial can be written as the divisor times that x is a times, it's multiplication, quotient plus remainder. So if you need to pause this and get this in your notes. Here's a numeric example. 27 can be written as 2 times 13 plus 1. So I snuck that in there just to give you a landing place. All right, we'll go back to this. So this is the factor theorem. Come on back when you're ready, okay? All right, ready? So here's the factor theorem. You need to get this in your notes. If the divisor is x minus a and a polynomial, we're going to call them f of x, we have this. My polynomial can be written as the factor times the quotient plus the remainder. So think about this. If x equals a minus a is 0. So 0 times any number is 0. So I'm allowed to just do, ooh, that looks awful. F of a is my remainder. This is I can plug things in. So go ahead and get this written down. Take a minute. When you're ready, we're going to add this piece. This gives us an easy way to find it, the remainder of a polynomial when it's divided by x minus a. Okay, this gives us a really easy way to find that. All right, I'm going to move on, but you can pause this. Okay, let's find the remainder of this polynomial divided by x minus 2. If we went back, we let x equal a. What I did is I set x minus a equal to 0 and solved for x. So if x equals a, I'm going to go do the same thing over here. So x minus 2 equals 0, solve for x. So x is equal to 2. So I'm going to evaluate this at 2. So I'm going to evaluate p of x when x is 2. So what that says is this polynomial evaluated at the number 2 is going to be, anywhere there's an x, I'm going to plug in 2. Minus 5 times 2 squared plus 6 times 2 minus 4. So let's see what this equals. We've got 8 minus 20 plus 12 minus 4. True? So however you'd like to shake this out, I'm going to do it from left to right. So 8 minus 20 is a negative 12 plus 12 minus 4, which is 0 minus 4, which is negative 4. So I have a remainder. Therefore, x minus 2 is not a factor of this polynomial. Okay? It's not. Done. Let's try another one. Let's find the remainder of this polynomial. Is x minus 2 a factor? So x minus 2 equals 0. Add 2. So I'm going to evaluate this at 2. I'm going to eval p of 2. So 4 times 2 cubed, that's a 2, plus 3 times 2 squared, plus 2 plus 2. So 4 times 8 is 32. 3 times 4 is 12, plus 4. So 32 and 12 is 40. 4 plus 4, shnikes, 48. No way. X minus 2 is not a factor. Okay? All right. So your math practice. Are these problems 5.4 in the book? So please go to the back, grab a book, take a picture of those problems, or write them all in your notes. I'm asking you to do 9 through 19, 49 and 51. You're going to do a little bit of long division and a little bit of using the factor theorem, okay? Make sure you have this done by Monday. There is no rest for the wicked. This lesson took maybe 25, 30 minutes, so you have the balance of class. I expect you to be working. I know that Mr. Anderson is going to let me know if you're not. You guys have a lovely weekend. I'm sorry I couldn't be there today. Make sure you do something nice for yourself. Take care, and I will see you Monday. Thanks.